My name's Graham, and I head up the data science and machine learning work for FSX AI. I'll be walking you through the technical process that we're using to provide some of the analytics that you see on the dashboard. The very first thing that we do for our code is we scrape the web for news articles that talk about food supply risk. The news can be about any type of produce, and what we're doing is aggregating actionable news so that we can predict the risk labeling of each of the news articles. The second thing our code does is actually get our ML models, machine learning models, to make predictions about any given piece of news. So the AI will identify for us the commodity and the country in question. And importantly, it'll also predict for us how much risk that news presents for food supply through the use of a risk score. That score is similar to how banks use a credit scoring system to rank borrowers' risk. Except here, we're developing our own system that is derived from Professor Teng's Food Insecurity Early Warning System. Of course, to transform the news into machine-readable formats, it's still a data science exercise, which means you have to clean and pre-process the data for natural language processing. Once those predictions are made, we have a report-generating script that allows us to summarize the insights and risk scores that our machine learning models have inferred from the news into a single, easy-to-read report. This report also makes a proactive recommendation based again on our risk scoring system as to what you should do next in terms of, say, sourcing for other suppliers. We've also got other features in development, which I'll talk about later. So far, we've been talking about food supply risk from a global macro level. We're also creating an IoT-enabled dashboard that can provide analytics for a more granular level of detail, such as, say, individual crop yields in one part of India, as well as on a per farm, individual farm data stream basis. In terms of partnerships and commercial platforms, we are intending to integrate our code with the machine learning features of IBM Watson Studio, and we'll also be hosting the data on Microsoft Azure, as well as linking our systems up with agri-tech platforms like FarmOS. Okay, so what I'm going to do now is I'm actually going to show you some of the code in the first version of the report generator and scraper that we're using. Okay, so in this particular notebook, we're using Python here. And as I mentioned, the first thing that we do is we scrape the web. So scraping simply means that we take website text from a news feed. In this case, the sample website is foodnavigatorasia.com, and we're trying to find ourselves news articles about rice, okay, about rice. So when I run the code, which is using an open source Selenium scraper browser, what happens is that you can see here separately a window is opening up where the algorithm is actually scraping the news. So without doing anything with my hands off, it's already automatically going page by page in order to scrape the news articles, as you can see there. Of course, I'm going to terminate that process because I've done that scraping already. And then what happens is we want to end up with the scrape data looking something like this. All right. So what this looks like here is the actual scraped .csv file, whereby we have the date, the title, the introduction of the text, the URL. This is essentially the raw data that we scrape. All right. And what happens is that we go through pre-processing. In this case, we use spaCy for lemmatization and tokenization based on a bag of words model. Bag of words model is what we need in order to feed it into a conventional scikit-learn machine learning model using anything from random forests, decision trees, gradient boosting, support vector classifiers, and also k-nearest neighbors. This is one type of modeling, which is probably the most common when it comes to machine learning models. We have, however, found in our backtesting that BERT, which is a pre-trained language model created by Google, trained on Wikipedia, which has already been trained on a large corpus of English language texts. We find that the pre-trained BERT model has a better performance and better understanding of the syntactic dependencies and the context of language. In plain language, it just means that there is a deep learning neural network created by Google that is open source that we are using, which we find does a better job of classifying news as whether it is risky, neutral, or say stable as regards food supply risks. Okay, so basically after running all of the models, all right, we want the final output to look like this. This is the final output. And what we see here is that it's already been categorized in terms of this article concerning rice and the fact that it concerns the country of Thailand. This article here says that, okay, Thailand's position as largest exporter of rice in SEA at risk because of weather problems, economy problems, quality problems. So therefore, the AI is able to understand that it's a risky set of news and it assigns a negative score to it. All right, and we understand it's talking about rice concerning Thailand, and it's a supply shock. Okay, what happens then is, okay, once we have that prediction that's been made already, we want to have a report generating script that will give you actionable insights based on those predictions. So when we run that script on that piece of news concerning Thailand's rice supplying capacity being compromised, this is what the report writer will actually generate. So it's running there now. Okay, it says here that this is an automatically generated report for this particular news article at this date using this URL. Our engine has identified that the article concerns risk towards the supply of rice by Thailand. It's in capitals here, rice by Thailand, because of the fact that, you know, that variable, that output in the text will be different depending on which article. So because of the fact that Thailand is the world's second largest supplier of rice, it's got a pretty good score of 19.2. Okay, and what this means is that because it's got a higher score, it's going to have a lower score now because of the fact that, you know, Thailand being such a big player, if bad news concerns Thailand's rice supply, then it's going to be more severe for us as Singapore, as a Singaporean importer, as compared to, say, Spain. If Spain has got rice supplying problems, it's less impactful for us because they're nowhere near as large a supplier as Thailand is. So because of that, from a score of 19.2, it drops to 17.28. You may be wondering where these numbers come from. These are placeholder numbers at the moment. But again, we are going to be incorporating Professor Teng's risk supply, food insecurity, early warning system framework. What that means is that the custom weightages that are based on his academically reviewed system will be incorporated so that we have our own custom weightages, custom penalties to better reflect the magnitude, the gravity, the impact of these types of food supply risk news. Okay, so that is the prescription. And then that's the diagnosis, sorry. And then the prescription is that, okay, currently we recommend choosing suppliers with a minimum risk score of 2 for rice. Therefore, we recommend looking at these other suppliers, and the system generates automatically other suppliers apart from Thailand with a minimum score of 2 and higher. Okay, and also because this article has to do with because it is a news article in the English language, it's going to not always pick up every other entity that may be of interest. Let's say other countries are explored in the article, and it does talk about Vietnam, it talks generally about Southeast Asia, then our use of the SPACY named entity recognition visualization allows users to quickly see, oh, okay, this article also talks about these other countries and regions that are worth exploring. The other thing that we are doing as far as language is concerned is we are exploring a summarizing AI. So using another kind of transformer, not too far away from the transformer neural network that we use for BERT, we also are experimenting with an AI that allows us to summarize language. So let's say you are a risk analyst working for the Singapore Food Agency and you have to like trawl through like hundreds, maybe thousands of articles at work. That's quite difficult, that's very cumbersome. So we toying with the idea of creating a way to summarize that using Hugging Face's T5 Transformer AI. And what this does is when you run this, the first thing it will do is to actually collate all of that text, right? Okay, I apologize. It's taking a little bit longer than usual. Okay, so what happens is that when we run the summarizing algorithm, it will any moment now print out what it thinks the summarization of this text should look like. And right here, it's already summarized all of this chunk of language into a few sentences. It's not perfect. I think that it has truncated the language too much, but it's just a preview of some of the other things that we are toying with in terms of improving the capabilities of our engine. So far, I've been talking about the national level. That means, looking at Thailand as a whole, India as a whole, Vietnam as a whole. It is also possible for us to run analytics on regional level information. So if, say, you have a data set that looks like this, which gives you detailed information on crop production yield, surface area of the farming land, which district and state in India, which year of harvest and the seasons and the crops that are being harvested, it is possible to draw analytics on this into a nice visual piece. So this is another type of dashboard that allows us to explore one more level of granularity. So from now national level, we go to a regional level of data feed in terms of farming data. And for example, you can actually pinpoint and have a look at what the majority of the crops are. So no surprise here, right? The largest representation of crops come from rice and maize, which are all staples of India. And then we can see all the other types of crops which are reported by the Indian government as regards crop type in India between the years of the late 90s to 2012. That's something that visualization is capable of doing in terms of having more information. It's also possible to draw correlations. Correlations simply mean that, okay, which factors seem to have a greater impact on production of crop yield. And for some reason, we do see here that the state that you're in India is one factor. Another big factor is the season. Okay, that's why it's a deeper blue color. Tells you that there has a greater correlation in terms of crop yield. This is of course a little bit abstract, but if let's say we wanted to deep dive further, we can also draw visualizations in terms of a deep dive of what uh, variable has a greater correlation to production. And we see here that for whatever reason, coconuts apparently are not very difficult to grow. They have a deeper correlation with productivity. Kerala, for whatever reason, has got a strong productivity. Although these correlations are less than zero point 0.5, it's just something that we can explore further in terms of trying to bring up granular data and data analysis. Okay, so data analysis of itself is not cutting edge. All right. What is unusual, however, is that the partnerships that Zaid and Nazir are trying to bring on board will also go at an individual farm level using sensor-based IoT. All right. So if we had a tech-enabled farm with sensors linked up to an IoT and the API that feeds into our dashboard, which we are developing the data partnerships for, all right, we could see data that is as granular as the UV level, the water level, whether certain types of fertilizer are used, pesticide usage, and how that corresponds with crop yield. So what all of this means is we are developing a risk decision engine that can provide a dashboard of insights at a national level, a macro regional level, and also at an even more granular individual farm level, which will then enable whoever the user is, whether that be government, a retailer, or farmers and growers, it will enable all parties involved, subject to their own individual requirements for data and the dashboard, to have a 360 view of food supply risk factors, whether that be at a national level or a regional level or an individual farm level. Okay, so thank you very much for your time. That's the end of our presentation.